Day 3, rules of differentiation. You're going to get a few more rules today. But hopefully by now you're getting set with the other basic derivatives. Okay, rule number 7, power rule for negative integers. If n is a negative integer and x does not equal 0, then d dx of x to the n power, where again n is a negative number, is n times x to the n minus 1 power. This is basically the same as rule 2, except now n is a negative number. So say we had x to the negative 1 power. So the derivative would become negative 1 x to the negative 1 minus 1, or negative 1 x to the negative 2 power, which can be written as negative 1 over x squared. So let's look at some examples. Okay, so in this one, find an equation for the line tangent to the curve y equals 1 over x at the point 1, 1. Oh, go figure, the thing I did earlier was y equals 1 over x. You're going to want to change this. This is where your exponent rules are going to come in really, really handy. That I don't want to, okay, you can use the quotient rule here if you want, but there's a much simpler way. We're going to just simply rewrite this as y equals x to the negative 1 power. The negative 1 power tells me that the x belongs in the denominator, not in the numerator. But for derivative purposes, it's much easier to do the power rule than the quotient rule. So to get y prime, I use the power rule. Negative 1 times x to the negative 1 minus 1 power, which is negative 1 x to the negative 2 power. Now we remember we use a negative exponent to bring the x up into the numerator, so we're going to get rid of it so we can put it where he belongs. So y prime is really negative 1 over x squared. Now they didn't just ask for the derivative on this one, they asked you to find an equation for the line tangent to the curve y equals 1 over x. At the point, hey, they gave you your x and your y value, all you have to do is figure out the slope. Well, y prime evaluated at 1 is going to be negative 1 over 1 squared, or simply negative 1. This is your slope. Because remember, that's all a derivative is the slopes of the function. So at 1, my slope happens to be negative 1. So now we can write the equation on our line. Y minus my y value of 1 equals the slope negative 1 times x minus the x value, which is also 1. And you get this. You do not have to clean it up from here. You can leave it alone. Okay, let's try another one. Negative integer powers of x. Have it again. Find the equation for the line tangent to the curve y equals at the point 1, 2. Again, they gave us your x, y values. Now, some people are going to be tempted to take this one and do the quotient rule, which you could, but again, because we have a power down here, we can bring him up. The two, leave him alone. This is one of those things you need to recognize, that this is y equals 1/2 times x squared plus 3 over x. And now I can take this x and rewrite him as a negative power. So I have y equals 1/2 times x squared plus 3 times x to the negative 1 power. Now, some people are going to go, oh, so now you just change it from a quotient rule to a product rule. No, I'm going to multiply. I have a bunch of exponents, same base, so I can multiply. So I still have y equals 1/2 x times x. Well, I have exponents. 2 minus 1 is just 1, so this is going to give me x plus 3 times x to the negative 1 power. This is just a constant. We don't have to touch them until the very, very end. So my y prime is going to equal 1/2 times whatever the derivative inside the parentheses is. Well, derivative of x is just 1. X to the first power, I bring down to 1. 1 minus 1 is 0. X is 0, 1. This guy is going to make this positive negative. So it's minus 1 times 3x, and negative 1 minus 1 is going to give us negative 2. So y prime, we're going to clean it up a little bit, is 1/2 of 1 minus 3x to the negative 2 power. Only thing we have left to do is rewrite it so we can plug numbers into it. So it's 1/2 times 1 minus 3 over x squared. And just leave them alone. For now, just leave them alone. I need m. So if you guys are going, well, can we step this out? Yeah, find the derivative, plug in your value for x into your derivative, that gives you the slope, and then do your equation of the line. Quick, I don't want to say 3 quick steps, but this one just had a lot going on, and if you didn't like doing it this way, do the quotient rule. I'm not going to tell you you can't do something a particular way. Okay, so we got to find our slope. M equals 1/2 times 1 minus 3 over, my x value is 1 squared, which is just 1/2 times 1 minus 3, which is just 1/2 of negative 2, which is negative 1. There's my slope. So y minus my y value of 2 equals my slope of negative 1 times x minus my x value of 1, and we're done. Okay, I know some of this you're going to go, what? This is kind of, you'll get used to some of these problems. Okay, so they gave you another one. Notice this time they did not give you an x value. So you have to calculate your x value. Okay, cool. If x is 1, what is y? Well, so y is going to be 1 cubed plus 1 over 2 times 1. Or 1 plus 1 over 2, which is 2 over 2, which is 1. So my point is 1, 1. Again, because I'm trying to show you negative integer powers, we're going to continue doing the problem the same way. So you're going to remove the constant out of the way, so it's 1/2, and then it's x cubed plus 1, and then once I took the 2 off, I was left with just x. So times x to the negative 1 power. This way I can distribute my x through, so I have y equals 1/2. 3 minus 1 is 2, so x squared plus x to the negative 1. Now I can do the derivative on the inside. Because this is a constant multiplied by something else, the constant's not going to go anywhere, not going to change. Again, this is something I have shown you in class of why you don't have to use the product rule when you have a constant. Okay, derivative of x squared is 2x. That negative is going to make this guy this positive. This negative is going to make this guy negative. So negative x, negative 1 and negative 1 is negative 2. And then rewrite it in the format of how we can use it. So y prime equals 1/2 times 2x minus 1 over x squared. There's our derivative. Okay, but that's not what they asked us for. They asked us for a line tangent at this point. So I need my slope. So m equals 1/2 times my derivative at 1. So 2 times 1 minus 1 over 1 squared. So this is 1/2 times 2 minus 1, or 1/2 times 1, which is 1/2. There's my slope. So y minus my y value of 1 equals 1/2 times x minus my x value, which is also 1. And that's what you get. So we had to find our slope, then we had to find our slope, we had to find our derivative, then we had to find our slope, which is the derivative at that x value, and then we were able to plug it in. Okay. So second higher order derivatives, the derivative y prime equals dy dx is called the first derivative of y with respect to x. The first derivative may itself be a differential function of x. If so, its derivative is the first derivative may itself be a differential function. Okay, so you can go into do the second derivative. So y double prime equals the derivative of dy dx equals d dx times dy dx, which is going to be d squared of y dx squared. So let's just say the second derivative of y with respect to x the second time through. This is the second derivative of y with respect to x. So, and we do call it double prime. And if y double prime is differentiable, its derivative, so y to the third power, is just d cubed y to the dx cubed. So it's saying the third derivative of y with respect to the x 3 times through. And so on and so forth. Now, once we get beyond that, we start doing that super n power. And what I need to point out to you guys is the fact that you cannot use, you're not going to continue using the values the way we were doing. You're not going to do 4 little slashes up there. The multiple prime notation begins to lose its usefulness after 3 primes. So we use y to the nth power kind of thing to note the nth power. So if I had the fourth, it would be y, and then the 4 would be in parentheses to identify what it is. Only after the third would you do this. Okay, so finding higher order derivatives. They're just asking you to go through and find the higher order derivatives. But they're asking you to find the first 4, so you can't just jump to the fourth one. So this is y, so y prime. All power rules. So this is going to be 3x squared minus 10x, 2 times 5, plus 0. I really don't need the plus 0, but I put it there to show I did it. Y double prime, 3 times 2 is 6x, goes down a power, minus 10. This is a power of 1, so it's going to go down. And I don't need the 0 anymore. The derivative is 0, 0. Then we get to y cubed. Okay, third derivative. This is a power of 1, so this is just going to be 6 minus 0. Didn't need it, but I figured it doesn't hurt. So the fourth derivative is 0, because all I was left with was a constant. 6 minus 0 is 6. Derivative of 6 is 0. Because remember, at this point, this guy's a horizontal line. So let's do the first 4 again. Y prime, and if you want, pause this and do and see if you get the same answer I do. So this is 4x cubed plus 3x squared minus 2 times 2 is 4, so 4x down 1 plus, this is just 1 minus 0. Didn't really need that, but I'm really showing I did the derivative with it. Y double prime, 4 times 3 is 12x, bring down a power, so 2. 3 times 2 is 6, plus 6x, minus 1 gives you 1, minus, this here becomes just 4, plus 0. Consider this me having done the math on these two. Left with plus 0, again, after that it's just 0. Okay, so the third derivative, 12 times 2 is 24x plus 6 minus 0. This guy here went up to 0 again. And then my fourth derivative. This one here, I'm just left with 24, and derivative of 6 is 0, so just 24. So there's my first 4 derivatives. Do you need the plus 0? No, but I'm putting them in there to make sure you understand that I am losing my constants, that I was losing my constants throughout. Okay, oh, there we go. Let's throw a negative power in there so you can see what happens. Again, they want the first 4. So y prime equals x to the negative 2 power. Oops, I forgot the negative in front. Bring the negative 1 down, and then subtract 1, negative 1, and negative 1 is negative 2, plus 2x. So y double prime. -1 and -2 is going to give me positive 2x. And it's still going down a power. Look at -1, -2, -3. It is going down a power. Plus 2. These are going down a power 2. 2, 1, 0. Then I have y to the third power. The third power. The third derivative of y. 2 times -3, -6x to the -4th power. Plus, and that guy is gone. So then we go y to the fourth, or the fourth derivative. Negative times negative gives me positive 24, x to the -5th. And we're done. So notice when you start with a positive power, it's going to go down to 0. You can keep taking the derivative, you'll eventually get to 0. And guess what? Once you get to 0, you're done. 0, 0. But if it starts with a negative power, you're just going straight for negative powers. -1, -2, -3, and so on and so forth. Okay, so let's do a little application problem. We may only do one of the two, and I'll just have you guys do the other one, see how you do. I'll give you the answer. So we have on here, an orange farmer currently has 200 trees yielding an average of 15 bushels, that's supposed to be bushels, of oranges. So we got 200 trees, 15 bushels of oranges per tree. She's expanded her farm at a rate of 15 trees per year. So notice it's a rate of change, 15 years, 15 per year, while improved husbandry is improving her average yield by 1.2 bushels. What is the current instantaneous rate of change for her total annual production? This is going to be a product rule. And so instead of me writing things out, we're going to use T for trees and B for bushels. So we have T, we have 200, and T prime, what's the rate of change, is going to be 15 trees. And then our bushels, we're right now getting 15 bushels, and B prime is 1.2. And now what we can do is we can actually write up this information, because what we have is a T prime B plus B prime T. Or in this case, 15 times 15 plus 200 times 1.2. So 15 squared is 225, plus 200 times 12 is going to be 24, so this is going to give you 240, because I would have moved my decimal over twice. 240, so we get a yield of 465 bushels per year. So, and again, word problems deserve word answers. This is what is the current rate of change of her total annual production of oranges. The total rate of change is 465 bushels per year at this rate. Now, because the video is getting kind of long, I'm not going to do the last problem, but it's going to be done the same way, only this time I made it an apple farmer. But I want you to know on this one here, I'll give you the total, and I want you guys to try it and see if you get it. This is going to be 390 bushels per year. And see how you guys do on this one. All right, this is the end of section 3.3 after 3 very long videos. I'm happy to say we're done, and good luck on the homework.